Hey guys, so just put up an example or a video of the two different kind of situations we see with case three. So what I'm going to do now is just make a video real quick on case one and case two to help you guys remember how to do this. All right, so if we look at these two problems, first one we're going to look at is number 5. So if we look at this one, just remember your cases. Since we see an exponent up top and it's only 1, and the exponent on the bottom is 2, since the exponent on the bottom is bigger, we know that this is a case. Oh, that was bad. We know that this is a case 1 type of problem. All right. So since it's the case 1, we know in this case, like what it affects is our horizontal asymptote. And any single time that we have a case 1, our horizontal asymptote is always going to be 0. All right. So you're going to make that dotted line going right along your x-axis right through 0. Every single time you guys have a case 1, that's always going to happen. All right. Now, everything else, we find the same exact way like we just did in our last problem in case 3. So when we go through and find our vertical asymptote, we always set our denominator equal to 0 and solve. Just be careful when you guys are setting your denominator equal to 0. A couple guys did this on the last quiz. When you're setting this equal to 0 and you're solving, you can solve by just adding the 16 to both sides, or you can factor it. Whatever way works best for you, just know that you should end up having two different answers or two different vertical asymptotes. So when we factor into x plus 4 and x minus 4 and we set them equal to 0, you guys should end up getting that x is equal to a negative 4, but also a positive 4. So that means we're going to go 4 to the right. We're going to make a vertical asymptote, and then we're going to go 4 to the left and make another vertical asymptote. All right. Just be really careful. All right. Sometimes they have 2, sometimes they only have 1. But especially when your guys' denominator, you see an x squared in your denominator, that's a really good chance that you're going to have 2, especially if it's minus another number. All right. Okay. So then after we go through and we find our vertical asymptote, now we want to find what our x-intercept is. So remember, for our x-intercept, we always take the numerator, we set it equal to 0, and we solve. Or we just take the top, set it equal to 0, and solve. So if we look at the top being 2x, if we set 2x equal to 0 and we solve by dividing by 2, it ends up just giving us 0. So my x-intercept actually ends up being 0, 0. So that's going to be the point right at the origin, right in the middle of your graph. All right. Last thing we have to find is our y-intercept. Now our y-intercept, we always plug in a 0 for x. So if I go and I plug in a 0 for x, we end up getting 2 times 0 all over 0 squared minus 16. But we know 2 times 0 ends up giving us 0. 0 squared minus 16 gives us a negative 16. Again, be careful with this, but if you have 0 on top, it's actually just 0. It's not a negative 16. So my y-intercept ends up being 0, 0 as well. All right. So now when we go through and we look at this graph, we have one horizontal asymptote, which we should only ever have one. In this case, we have 2 vertical asymptotes, and we only have that one point in the middle. But if we go to graph this, like you guys did on your last quiz, and we did a really good job with it, anytime that you know that you're working with a case 1 type of problem, and especially because this is a positive fraction, we know we're going to have an S shape in that middle, and that S shape is going to go from top left to bottom right, crossing through that intercept point that you guys had at your origin. Now, just remember your guys' rules for having those outside curves. They're never going to touch along the same asymptote. So on the left side, you guys should have that one curve on that bottom left corner. And on that right side, you should have a curve on that top right-hand side. All right, so that's what your graph would end up looking like for this case 1. Now, like I said, just because this is a case 1 and we have 2 vertical asymptotes doesn't mean all case 1s have 2 vertical asymptotes. Remember, some case 1s and case 2s could either have 1 or 2 vertical asymptotes. And we'll see on the next example when you guys only have 1 vertical asymptote what to do. Okay. All right, so that was case 1. So then if you guys look at problem number 6, which is right next to it. All right, so problem number 6, like we keep talking about, the first thing you guys want to do is identify what case that you are working with. So if I look at problem number 6, and we always look at our exponents, and we see that my exponent up top is a 1, and the exponent on the bottom is a 1, that means since the exponents are equal, you guys know that you're working with a case 2 type of problem. Okay, since you're working with a case 2, we definitely have a horizontal asymptote still, but it's not going to be like one set number. In this case, any case 2s that we have, we always divide our coefficients. Now remember, it doesn't matter what the order looks like in your fraction up top and down low. Like your x's can be all the way at the very end, and that's okay. But when we talk about dividing our coefficients, we talk about looking to see what's in front of x. So up top, we see that there's a 2 in front of x, and on the bottom, there's really a 1 in front of x. And you guys know that 2 over 1 is just 2. So my horizontal asymptote ends up just being a positive 2, because 2 divided by 1 is 2. So that means we go up 2, and we put that horizontal dotted line going through that positive 2. All right. All right, now when we go through to find everything else, just like we did on that last case 1, it's the exact same thing. So my vertical asymptote, I set the bottom equal to 0, and I solve that. So when I set x minus 3 equal to 0, I go and solve, and I end up getting a positive 3. So my vertical asymptote is going to be x is equal to a positive 3. So I go to the right 3, and I make that vertical dotted line. All right, my x-intercept, let me erase this so I have some room. My x-intercept, I now take the top. I set equal to 0 and solve. So I'm taking that 2x plus 1, set that equal to 0, and solve from there. So when I solve for x in this case, I end up getting a negative 1/2. All right, just remember that this is a point. So like when I write this x-intercept, it might look kind of sloppy because it is a fraction. But it's negative 1/2, comma 0. So that tells me that I'm actually going to the left on my x-axis a half a unit, and that's where my point's going to go. All right, last thing we have to find is then our y-intercept. And our y-intercept, we always plug in a 0 everywhere we see an x. So if I go to plug in a 0, I'm going to end up with 2 times 0 plus 1, and that's all over 0 minus 3. So when we have that, well, we know 2 times 0 just cancels out, so you just left with a 1 up top. 0 minus 3 on the bottom, well, that just stays a negative 3. All right, so then we end up with a negative 1/3. So my y-intercept, which I'll write below it so I have enough room, is a 0, comma, negative 1/3, because that's a point as well. All right, so when you guys go to graph this one, since it's negative, you know on your y-axis you have to go down. But again, it's not going to be perfect. Just put it somewhere in between 0 and negative 1. I know that's not great, but again, it doesn't have to be perfect. All right, so once you guys go through and you find all 4 of these things, remember what we talk about having one vertical asymptote. Whenever you have one vertical asymptote, here's where it's going to look like those basic shapes that we talked about again. So you guys have to decide whether this shape, since you have points, you already know one of your lines has to go like this. It has to go through those intercept points along your asymptotes. Has to. So you have to decide what the other side of the vertical asymptote is going to look like. Is that green line going to go on the bottom right, or is that going to go on the top right? And again, it doesn't necessarily matter what case you're working with. It really matters what exponent of x is on the bottom. Since you see an x to the first on the bottom, that tells you guys that these 2 green lines of the functions have to be in alternating sections. So that means that you are going to need a green curve in that top right section. If for some reason I saw an x squared on the bottom, that's when both of those green segments or both of those green lines would then be below my horizontal asymptote. All right, hope this helps going through each of these cases. If you guys have any questions, like always, just make sure you reach out to me, email me, and I promise I'll get right back to you. All right.